Good evening, everyone. This is Gaganjeet Singh. I'm a customer success manager from VAF. We are the official alumni engagement partner of CET Bhubaneswar. I welcome you all to today's webinar by eminent alumnus of CET Bhubaneswar, Dr. Satya Roy. Before we go ahead and listen to him, I request Mr. Sarthak. He's one of the student alumni coordinator from the student alumni relationship cell of CET Bhubaneswar to come forward and introduce Dr. Satya Roy.
Good evening to one and all. This is Sarthak, and I welcome you all to the fourth episode of Interaction with Alumni series by Web and organized by the SARC team of CET Bhubaneswar. So today we have among us Mr. Satya Roy, alumnus of CET Bhubaneswar batch of 2008. Dr. Satya Roy is currently working as a structural engineer in the Bridge Division of AI Engineers at the Pennsylvania office. He earned his PhD in civil engineering from the University of Austin, USA in 2019. His research interests are primarily in the field of bridge engineering that's focused on large-scale structural testing, detailed analytical studies, and enhancing the resilience of civil infrastructure through the use of innovative materials. Design and construction guidelines developed from his PhD research are now adopted for implementation in actual full-scale bridges. He holds a MTech in civil engineering from IIT Bhubaneswar. Prior to joining IIT, he was working as a bridge engineer in the LEA Associates of India, where he played a key role in establishing the bridge management system in the states of Gujarat and Odisha. Specifically, he was involved in bridge inventory, health monitoring, preparing the repair, and retrofitting strategy, including cost estimation of more than 1,000 bridges. He earned his BTech in civil engineering from the College of Engineering and Technology Bhubaneswar in the year 2008. He has co-authored 6 peer-reviewed journal papers, 3 referred conference proceeding papers. Furthermore, he was the part of 2008 organizing committee of the first ever Sanidhya, the cultural fest of civil branch. So without further wasting of time, I would like to hand over the meeting to Mr. Satya Roy, sir. Sir, please.
Thank you, Gagan and Sarthak, for your wonderful introduction. I don't know, whether I'm an eminent alumni, but I will definitely give you some hint and ideas, how the industry academia partnership for the development of sustainable infrastructure system works, how the research works to develop a some creative infrastructure system. What I believe personally, it is not a solution if it is not affordable. So the aim of the research, the goal of the research is to make every solution affordable to the common people, like in our field, to the common engineers, to the common industries. Okay, it doesn't mean only the big industries will get some big projects and they will implement some big technologies. Okay, so all the technologies should be used by every common industries and every common engineers, designers, architects, and all the researchers and scientists. Okay, with that, I am Satya Roy, and let me introduce myself in the next 2 slides. I will briefly describe my educational background and my previous experiences, and also whatever I am doing now. Then I will give you a brief idea how industry helped us to develop some beautiful things, like beautiful design guidelines. Some that is not in USA, not in India. Also, that is accepted by the whole world. Okay. So without wasting much time, I will now introduce my educational background. Okay, so as you all know, I graduated from with a BTech in civil engineering from College of Engineering and Technology Bhubaneswar. So I was quite privileged to be among my beautiful juniors, fantastic teachers. On that time, Padi sir, Sahu sir, Sabita ma'am, Sarat sir, Hemant sir. Of course, it is a sad news. He's I am very closely associated with Hemant sir. So we are actually quite privileged to be among all these eminent professors. Then after my BTech, I joined Lee Associate. Okay, so I got placed in a campus interview at that time. So in a Lee Associate, so that is LEA, Lee Associates. Most of the people, students, also don't know that, but that is one of the biggest consulting firm of India. and the head office is in Toronto, in Canada. Okay, so if you see being an engineer, if you see there is a list like at the end of every year there is a serial number for the all the engineering design firms. Okay, so I am fortunate to say, and I am glad to say, the company where I am working now, the Lee Associates, the ranking is much higher than the company I am working now. Okay, so only difference is the salary. So I was getting a low pay in India, but here your pay is very high. Okay, so Lee Associate is that famous. Okay, and after once I spent 5 years in Lee Associate as a bridge engineer, then I moved for MTech. Okay, I did my MTech in IIT Bhubaneswar, and there also my advisor was Dr. S.R. Das. He is a fantastic human being, I will say. Okay, he was not my advisor; he was just my friend. Okay, so then after that, so all these conventional methods. You have to appear like GRE, TOEFL, and apply for PhD. Then I thought I'll go for PhD. So I got a PhD in University of Houston. So here my advisor was Dr. Y.L. Moe and Thomas T.C. Su, and my co-advisor. So this Thomas T.C. Su professor is very world famous professor. As I will move through my slides, I will show his eminent work. Okay, you will see today, once I finish the presentation, you will go and search in Google. You will see how big he is. Okay. So, okay, next, my professional background. So I joined in 2008, and I left Lee in 2013. So between that, those years, so I was very privileged to be a part of the bridge management system that comes under asset management system, payment management, traffic management, all them different kind of managements are there in asset management. So bridge management is one of them. So I was actually selected for highway in CET, but fortunately, today when I connect the dots, I think how fortunate I was. Okay, I went to Gandhinagar, Gujarat, then I was placed in a bridge division. Okay, so that was the first time in India they were establishing one bridge management system. Okay, so it means you see now you are doing some your alumni management, so you are collecting some all the alumni data and putting in some records, and you are filtering. You can choose okay, then you have lot of options. You can choose okay, which alumni is belongs where, so you can choose that. So in that way, so in bridge management, what you do, you put each bridge data in a server. Okay, from any part of India or any part of, suppose, Gujarat, from Gujarat state, you can access a bridge data, and from that you can at the end of year, when you make a budget, how many bridges you are going to repair, retrofit, or you go to replace. So it helps immensely to take a decision. Okay, so then I worked in that 5 years were enough. Okay, I worked throughout the India. I worked in Pune in NH4 and Gujarat State Highway, and in Odisha we also established for the first time. That was a huge project. So we established also the bridge management system there, because the Lee has a experience from Gujarat, so we implemented there. But Odisha government was really strict than Gujarat. You must be knowing Pal sir from Odisha government. Okay, he was the head of this project, and he took care of this project very minutely. Okay, so then I was also working as a graduate research and teaching assistant in University of Houston, and that was within the period of 2015 to 2019. Then again, once I finished my PhD, now I am working as a structural engineer again in the bridge division. Okay, and I would say here my experience in Lee Associate really helped me to get a job in a senior engineer position here in AI engineer. Okay, so here also we do a lot of also innovative work. I will also show you some works there, like what we are doing here. So I will share my some experiences from Lee Associate and AI engineers in my next slides. Okay. So then we'll move to here, the research projects. So I have only kept in these slides the research projects I did during my PhD. Okay. In masters, it was funded by, like the government of India, you get some funding like from DST or you get some funding from a professor. But why I choose these projects? These projects we got from the industries. Okay. So we collaborated with industries, and we got a huge funding. Like you can see, like I have put the funding amounts. Okay. So we got huge funding in each project, and I would say we successfully finished all projects, and some of these projects become huge success. And yeah, so I will describe more. Right? So you see here. So the project one is like the performance of skewed reinforcing in inverted T, which was my actually thesis, like PhD thesis. So we did 3 years of research here. Then we did also like non-contact splices. Okay. So these two projects are funded by Texas Department of Transportation, as you can see. Then we developed one very fundamental behavior of like composite steel plate. I don't know like whether you know about composite steel plate concrete, but I will show in my next slides. Okay. And then I also do one consultancy projects. This was from a like water company. This is like from an environmental department. Okay. So in these slides, I want to express, the importance of the industry and the academia collaboration. Okay, you see like how much funds are involved here. So no professor can have like these funds like of your own, or any government cannot fund. This is like, how much. This is like maybe 30 crore in Indian rupees, 30-40 crore if you sum of all of them. Okay, so it is not possible even for an institute. So a industry has to fund it. They have to tell their problems. We are facing the problems in these areas. Okay, so I think the industry doesn't have like enough qualified persons to come up with like huge solutions. They ultimately come to universities. Okay, can you please help us to get the solution of these projects? Can you help us to finalize? Okay, how can we get rid of these problems in the real like when we are designing or construction. Okay, and the next very important aspects, you see, this is the most important aspects what I consider. A professor has to fund the PhD student. Suppose I was doing PhD here, so he has to fund me like he has to give me maybe $2,500 per month. So from where he will get? From him, so he will get from all these money from these projects. Okay, so so one project, so suppose if I take an example of the first project, which is the skewed reinforcing, okay, in inverted T. So that project has like I was only PhD students. There are 4 master students and 4-5 like summer interns from the bachelors from the. So you see like one project is funding at least 10 students. So that is shaping of 10 students future. Okay, so that's what I wanted to let you know like what is the importance of getting a project from the industry. Okay, so we like out of these four projects, I will explain in detail like what I did in performance of skewed reinforcing. Other research I will give you like little bit like hint or glimpse, like you can just take a look. Like if I know like I am not quite sure who are in the audience, but if you are like final year or third year, so I think you will understand much better. If you are in second year, well, then you can understand the approach. You see the pictures. Okay, you understand the approach if you are in second year or first year. Okay, so okay, with that I want to move the first projects. Okay, so this was a very interesting structure. Okay, so I just put it a inverted T. So here you see like, okay, let me, yeah, so if you okay, I hope like you can see my pointer here. Okay, so you see, so this is a bridge. You like everyone, all of you have seen this is a bridge. Okay, so this is beam. Okay, on like this, the longitudinal members are beam, and these vertical members called as column. You all of know, like all of know this definition. Okay, so if I go to next slide, next photo, I saw like column cross section. You must have seen a lot of bridge columns in this shape, like which is rectangular shape. But these inverted T's are very rare. You can see here the shape is inverted T. Now you must have read like, okay, design of T beam all in your third year or final year, but you never like I don't know like how many of you know about the inverted T. Okay, and I would say the behavior, the structural behavior of T, like the T beam, the original T beam and the inverted T was quite different. Okay, and if you start designing, you will see like various kinds of failure modes, various uh, various different types of design principles. Okay, so why we have to use the inverted T in bent column? Okay, you in this picture I have shown you. So this left side is a rectangular like rectangular beam. So this is an inverted T. You see, once you put a girder here, this girder means this one, this beam. Okay, and this beam represents this is called as the bent cap or pier cap. You must have known like abutment or pier, like the bridge components. This is a cap which is designed as also a beam. Okay, so you see, if I put a girder on top of inverted T here, or maybe a rectangular bend cap, you see the difference in the elevation. Okay, a lot of difference in the elevation. You can get the same clear height with a next slide. I will show a very interesting example. Okay, I don't know whether you saw it or not. I will show a very interesting example in next slides. So you see how much is the difference in elevation you can get like using inverted T. If you get this much of difference in elevation, so you imagine how much you can reduce the uh, height of this column. And one like a bridge or maybe one elevated corridor, you can say one flyover, maybe thousands of like columns. Okay, then you will be able to reduce like thousand pier, like the height of pier, like thousands number of height of piers you can reduce. Okay, so you now imagine how much you save in a project. And for Indian scenario, this is very important because this will help you also minimize the land acquisition difficulties. You have to acquire the minimum land. Okay, so what are the advantages then? So it increase the clearance, reduce the elevation of bridge, and it will, if it will reduce the elevation of bridge, it also reduce the elevation of the approach. Okay, then you can have a larger span with a, you can provide a larger span. And it also, you can see the both like cap here. This looks like aesthetically little bit better than the previous one. Okay, so okay, so I don't know, like, can you recognize this place or not? I can tell you. So this is the place, like this is the link road, the Kotak Bhubaneswar link road. Okay, so in my entire like career in India, I have seen only one place. This is the place where they use this, like in like inverted T. You can see this, they have used inverted T. Okay, so why they have used this, I will explain you a little bit. Okay, so this is coming under the national highway. So you see, if you go just little bit away from that link road chalk towards like Calcutta, you will see just you after 100 or 200 meters you will find a railway bridge there going on top of that. And you see, even before this there is, I think, Kathajodi or some other bridge. Okay, so you have to take a flyover which will just go above the chalk so that you can pass like beneath it, pass underneath the bridge, and that will suddenly fall below this railway bridge. Okay, in India, they don't allow to go over the railway doesn't allow actually to, some agencies doesn't allow to go on top of railway bridges. Okay, so that's why. So you have to go under the railway bridge. So in this case, only inverted T was the solution. You can see using inverted T, they can suddenly change the grade and come under the railway bridge. Okay, and when I was working in Odisha, so I was little bit aware of this, like problem. So like I was able to find out like, okay, so using inverted T, you can really help while you are going like multi-level flyovers or multi-level elevated corridors. Okay, so this will be a huge help actually. So I have given the design guidelines to Odisha government also. So maybe they will be implementing soon. I don't know. So I am not aware of the development. So yeah, moving to next slides. So I will just move. So you here you see this is a, like you can see is a straight inverted T, and here it is a skew inverted T. Okay. So even like straight inverted T, like even like you can see like easy to design. Okay. But if you consider skew, you can see like because of skew, there is a lot of torsion in the here. Also, you have to, like in civil engineering, the most problematic part is like shear and torsion. Okay, so you have to take care of them here. Like anyone can design like flexor, like bending, punching. You can, but like shear torsion design is really tough. Okay, and you can see here. So here in inverted T, if you apply a load here, like for example here, so it will bend in this way, and also in in longitudinal direction, also in transverse direction. So in one point, you are getting a bidirectional bending. I don't know, like if you have any idea about bidirectional bending, but there is no design guidelines to design the bidirectional bending. So that is the huge challenge here. Okay. So yeah. So here you can see, now I will move like a little bit quickly. So suppose here this is a plan view of the inverted T in skew. What they used to do, so they used to fan out the bars like from 0 to 45 degree in this way. You can see like by doing this, you get like numerous numbers of different lengths of stirrups, or maybe like different kind of bars, I would say. So what they come up with this problem to our university, to our department. So professor assigned me, like my professor assigned me, advisor assigned me, Satya, can you come up with a solution, like what we can do? Okay. Then I went through like several like international and USA courses like SCI, ASTO, and some European course and Indian course. So then what I found, if you provide SQ stirrups, okay, you must be knowing now the torsional capacity increases with the length of the stirrup, like the area enclosed by the stirrups. Okay, so if you put a skew stirrups, so your area enclosed is increased, so your capacity increased. So what I told my professor, so Professor Mo, we can give this solution. Okay, and you see this will be implemented. This will be implemented in a real design, so they will not accept you. So you have to test it, you have to validate it, so you have to propose the solutions, you have to propose the guidelines, so that they will accept it. So because of that, this part is very much interesting, you can all understand. Okay, so we here I think we have made like 15 number of real beam like this to test. So this is the construction procedures. So we attach all these sensors to measure the strain displacement. Then you see like the formwork is done. Then we pour the concrete. Then this is like this was actually I don't like this will be a this is a self compacting concrete. Okay, you can see this is a self compacting concrete. Then some labeling we are doing. Then we are making the cylinders like as you guys also did. So cylinders too. Like to check the strain during the test. So here, this is the test setup. You can see, like this applies the loading positions. These are like big actuators. So actually, we have like for this test, we have also made this test setup. So you imagine how much money involved in these projects. Okay, so this is a really huge project. So, and like now roller support, rocker support, like hinge support and roller support. So these are the support conditions, like here. So this side is hinge and this is the support conditions. So this slide describes like all about the test setup, the construction methodologies, how we do the test, okay, how we acquire the data. So this was a huge challenge. So after that, like because everywhere you cannot spend that much of money to do some experimental setup and experimental work. So what we did, so we did some finite element simulation, 3D finite element simulation, so that our work can be used in other universities. Suppose you now you want to work in inverted T, so you don't have that much money to spend in experimental work. So you can take it from, you can take our model, what we made from the experimental work, we have already validated and calibrated. So you can use that model in your research. So yeah, so that was our contribution from this, and this was accepted for implementation. Now they are making a very big bridge, like 7-span bridge, which is around 500 feet. So they are now in like they will do the test to like finalize this project. So I was quite privileged, like my projects was implemented there. So this is the next project. So this was around like 700K. So you see like this is a column here. So and this is the foundation. This is, you must be knowing the pile, the drill shaft. And so this is the real bridge that we there was a problem here. There was, if I show you the plan view, you see, so this is the rectangular column. So this is the column reinforcement here, and this is a foundation which is called as the drill shaft. Drill shaft is a larger version of pile, that is like a monopile, which is a larger pile, like a single pile. So so if you see like both plan like reinforcement, from the top there is a big difference between, there is a very large spacing. So if there is no way now you can extend the drill shaft reinforcement into the column, because the column is column cross section is very like low, that is small, and the drill shaft cross section is bigger. So you have to provide a dual bars. So there were no guidelines actually. And you see, if you apply a load here, you will definitely get crack at this location. So we have to prescribe a design guideline for the spacings of this drill shaft to the column connection. So this was also a very successful project. And the same way we fabricated here maybe 15 to 20 specimens. You can see like this is the fabrication stage. Then this is our lab setup. Exactly, you can see we have exactly like replicated the field scenario here. We apply a beam here, then you apply actuator load, and this is the column, and this is the drill shaft, and this is the like foundation attached to the strong floor. Okay, then this is a like data acquisition system. Then yeah, the same way we did also the finite element simulation, like 3D finite elements, so that other university, other researchers or other engineers can use our work. So, and this was a very interesting, like pre-stressed concrete, reinforced concrete, okay, but this is called as the steel plate concrete. Okay, so you see there are like both sides we have put a steel plate, and these are connected by some studs, and and you have to put the concrete inside. Okay, so generally these are used in the nuclear containment. This is an example here on the top photo I am showing here. So this is a example for nuclear containment. Okay, so like these steel plate elements are from these nuclear containments. Like these are from Georgia. So like how much heat is produced in the nuclear containment. So based on that, you have to provide the thickness of the wall of the like that nuclear plant. So you have to do a rigorous like design analysis and simulation, and you have to also restrict the the radiations. So you have the design includes like very detailed provisions. Okay, so this was we also like had like large number of tests how to design, especially you see. So this will be designed as a membrane element. So there are like biaxial shear and out of plane bending involved here. Okay, so these are our test specimens. You see, this is exactly looks like what you find from the nuclear containment from the previous slides. So we make here these specimens we have made in our lab by ourselves. So this is the nuclear containment, like the wall structure you can see. Then we put concrete here. So this is like you can see top side there will be a steel, bottom side steel, and in mid there is a concrete. And so this is the world famous machine. Like this is only available in University of Houston, not even MIT, Stanford, nowhere in the world. Okay, so this is called as Universal Panel Tester. This is called a UPT, Universal Panel Tester. This is designed by Dr. Su, who is my co-guide, my PhD co-guide. So you can see this is the wall we have put here. We are testing. Okay, so this has like almost like 40 actuators. Means you can apply load at 40 points. Okay, and the beauty of this machine is you can apply a out of plane bending. So you can compress this way, this way, this way, and this way. All four way you can compress and put like you can apply compression and tension. Beside that, you can also apply a out of plane bending in this way. Okay, so like any kind of forces you encounter in this world can be simulated here. I am not talking about the magnetic, like all those hyperloop, those kind of like you can apply cyclic behavior, you can apply earthquake, you can apply all these like civil engineering forces, you can apply all here. Compression, tension, bending, shear, flexor, every force you can apply in this machine. Okay, and these are all like this is a hydraulic actuator, so you have to apply. So this is designed by Dr. Su in 1980s. So because of this, he became actually really world famous. If you search him, so you will like a lot of professors. He's famous like among all engineers and researchers in every like universities. So yeah, this is our test setup. So yeah, out of that, so we from that experiment, so we find out this stress strain behavior, which is very fundamental work. So now if I become professor somewhere, maybe I will use these equations to do some further analysis, some further research. Yeah. So and this slide I have put for like for all environmental people. I don't like I'm sure you must be aware of like trickling filter, rotating biological contractor. Okay, those kind of terms you must be aware of. And this is the filter used in that system, trickling filter, rotating biological constructor, so we have to actually what we are doing here, we are checking the strength of this filter media. Okay, and this is a bio-pegged plastic tower. Here actually what happens, you have to put bacteria inside all these micro organisms. Then when water will go, like sewage water or water will go, they will catch the nutrients, and so then the output water will be clear. So these are all these like channels water can go through. So we are testing here like to check the strength, like the buckling strength and the strength between these sheets. Like these are attached with a gum, like adhesive. So you can see here, once we test, so we found like you see all these intersections like junction points are felt in buckling. You can see all like buckling. So from this experiment, we found this load deflection curve. This was a consultancy project actually, but I want to say here. So once you become a researcher, so you can do a whole lot of things, whole lot of works, not only in structural engineering. So if you are in a structural engineer, you can work in environmental engineering, environmental work guy can. So now every research is like interlinked. You see, we also deal with the mechanical people and the electrical people in data acquisition, and we put like so many sensors, we take their help to fix the sensors. Okay, so now the research has become like very dependent with like other departments, other industries. So yes. So once I finish like my research work, then I want to, I will take only more 5 minutes. So then I want to show like what I am doing now as a structural engineer. Okay. So this is a old steel bridge in USA. In my research, I was dealing with all the bridge components in an element level. This is a beam. This is a column. Now I am dealing with the whole bridge. Okay. So you can so this was a very old bridge. So we are like estimating how much load this can take now. Can we because I think this was designed in 1850. So at that time loading conditions were completely different. In 2020 the loading conditions are completely now different. Big trucks. So can all these load can be carried by this bridge or not? So you can see here I am here in the uh, in the lift device. So we are attaching like some sensors here like LVDTs and strain gauge and the laser gauge, so that, and in also these photos, so we are attaching in some points like we cannot, because this is a huge bridge, you cannot instrument the huge bridge, the all over the bridges, but you can instrument at certain points. Okay, you have to find out which points are very critical points. So you have to instrument those critical points. Okay, and then finally we are doing the real load test in lab. You take actuator, you apply the load in a like laboratory conditions, but here you have to do the test in a real like you have to take a truck on the top of the bridge. At what point what loads are coming, you have to find out from this. Then yes, so here I put this photo, like some of the like very beautiful bridges where I worked with. I should put like some photos from India also. These are like very close to my heart. You can see like this is a balance cantilever, like two girder bridge. This is a like 1800 bridge. This is Golden Bridge, like from Gujarat, and this is a frame type, all kinds of bridge like I have put here to show you. In India also, like long time back in 1900, we have also designed and constructed a like a fantastic lot of beautiful bridges. We have like at that time, I don't know, like we didn't have that technology, but you can see the span length and the huge bridge. And this was in the Bhuj. This bridge. This was damaged in earthquake, Bhuj earthquake. So I was able to do the inspection here. So yes. So I also like got a lot of experience from working in Lee Associate. Like I got familiar with all kind of bridges. So yes. So in this side, I have put like you can take a note on like he was my colleague in University of Houston. Now he's in India, Pune. So he has opened a consultancy for the like students who want to go abroad, and how to prepare their CV, how to prepare their like SOP. He's helping a lot, and he knows me very well. And if you guys want to contact him, definitely you can contact him. Like I have already conveyed by message, like some of my juniors from my like state college, so they will approach you. Then he has opened a like big company like for the students, and he has a very good track record. So he has sent like a lot of students outside with funding. So yeah, you can contact like Dr. Hemant Dhonde. This is his LinkedIn profile. You can like uh, mm, search him in the LinkedIn, approach him for sure. And yes, so I think that's it. And yes, like thank you
Great.
so much. And like at last, I okay, 1 second. Okay, at last I
Yes,
want
yes.
to tell you, like at this point of time in CET, don't forget to build friendship, and like enjoy the time in the CET, because this is the beautiful time you have got. You have to enjoy. You have to enjoy as much as you can, because you are going to miss this time after you get out of the seat, like like college, like CET. You will always miss those days. But you cannot get back those days and you cannot go back there. So yeah, enjoy as much as possible. Thank you so much, guys. Thank you so much, my audience. And thank you. Like, I don't know, like if my CET professors are here, but I want to thank you also then. And thank you for inviting me. Thank you.
Thank you so much, sir. Like, this is the best webinar we have done so far. Like, there's so much of projects, and we're really like, I know students are already pumped up. They're already, you can see Q&A is just coming up like anything. Without further ado, because we are left with 20 minutes, I invite Aishwarya. She's one of the student alumni coordinator, and she'll be asking you questions from the audience, and uh, just guide your juniors towards, like, this is the best advice you have given. Just enjoy the time at CET as of now. But let's take up some questions live. Aishwarya, are you there?
Yes, sir. Yes, sir. Thank you, sir.
Great. Please go ahead. Yeah.
So the first question we have is by Asirbat Samal. Sir, how to approach for off-campus placements as a fresher, as the scenario for on-campus is very bad, as very few core companies are coming for our department.
You see, like, uh, I let me tell you, like, I will tell you in like very short. We are the first guy. We are in third year in 2007. We organized the first Technofest. No, even you see, like, not even electronics branch, not even electrical ones. We organized a national level Sanidhya Tech Fest. Okay, at like in 2007, we have people from IIT Delhi, IIT Guwahati, and NIT Rourkela, NIT Warangal, from all over the India. Okay, so we were able to gather like huge audience actually in first year 2007, and we are the first guy, like we are the first batch who has organized the study tour. Okay, so we have gone like we are there in 33 people. All of them we have gone like Mumbai, Goa, Bangalore. We have organized a study tour. All 33 people we have gone, and you cannot imagine like how much we spend for people. Only 3,000 rupees. Only with 3,000 rupees we spent 20 days, like Goa, Mumbai, Bangalore, Chennai, all over there. So what I'm saying, you have to take the initiative. Okay, you have to take what I mean to say, you have to create a profile. First is profile of the civil branch with all your professors and with all your students and with all your students contribution and the profile. Okay, so once you do that, then you have to create a okay, let me tell you one thing. It is rare a civil engineering student is in a placement cell. I am telling the truth. It is very rare. They only sit and they think like, okay, some maybe they will bring some core company campus and something, and we will do, like we will go. It is not like that. You have to be involved in placement. You see, like, what is going on. Suppose I now told you the whole story, okay, how bridge engineering works, how other engineering works. If now I approach a company, so I can explain the company better. A electrical or a electronics or computer science guy cannot explain what is happening in civil engineering. So that is one thing. And on that day I was talking to Sarthak and Aishwarya, and I found even like we people don't know the company's name. What are in India, not companies, only Vedant. You will go to Vedant, what you will do? You will do some maintenance work. You will go to NTPC Nalco, you will do some like paperwork. Okay, you will go to some manager, assistant manager. But if you do like really some work on the core field, or you do like, which I call always like research oriented work, okay, you have to go to some real core companies. Not you go there and be settled. You have to go to some real core companies. Like I know a lot of international companies are now in India. They are now, like all they are attracted to India because now India is a huge market. Okay, you have to approach them. Like you have to approach the people who can understand your background. Don't approach only HR. Okay, if you approach HR, he doesn't understand, okay, how civil engineering works. So you have to approach the people who understand your background. Okay, then I was talking, we can make a club so that we interact with our seniors. I know like a lot of people also here, they work here, okay? So we can definitely make a club, and we can definitely interact with each others. And I was thinking like, why don't we interact on a monthly basis, or maybe in a 6 months we should interact, like we are doing what, like you can know. So within a short period of time, I will not be able to explain you everything, but if you interact within a periodic interval, definitely we can express a lot, we can discuss a lot.
Thank you, sir. The next question is asked by Piyush Satpathy. What was your very first step after completing MTech so that you got admission in University of Houston? What was the approach?
Yeah, okay. So let me tell you. So actually, I was planning to do the masters in like in USA. So I at that time I prepared for GRE and TOEFL. I appeared that. But when I actually it is very difficult, because at that time I did not know. So I don't have enough project and enough publications in my profile. So I did not get a scholarship in masters. So what I thought, like I would join a I would appear get and join in a IIT, so that, because in abroad, they only know IITs, they don't know anything else. I'm telling you. So I knew that stuff earlier. So you have to join a IIT. I joined IIT Bhubaneswar. Then, because my goal was to come abroad and do some like course engineering research. So and you will be surprised, the TOEFL is valid for 2 years, okay, but GRE is valid for 5 years. I went with my previous GRE and I appeared TOEFL once more time. So yeah. So but before that, you have to make your profile strong so that you get the scholarship, okay, because here you spend a lot of money in crores, you cannot afford. In crores you have to if you do masters in a reasonable college, if you don't get funding, then it will be around like 30 lakhs. If you go to little bit better college, it is like 60-70 lakhs. If you go like top 10 Ivy League, you spend in crores. So what I'm saying, you have to create your profile to get some scholarship. You have to do some research publications. Okay, let me give you a best example. So I was working with a Chinese guy here during my PhD. His name is Jiaji Wang. Jiaji Wang, you can search him. He was from the best college of China. If you search the best college of Asia, so that university will come. Tsinghua University in Beijing. That was the best university of China. He was from there. Okay. So I was with him. I was working with him. So if you see his profile, he has 50 publications. He has 200 citations. He has started publishing from bachelor. At that time, I did not know what is a publication also. I am telling you. This is the truth. At that time, I didn't know what was a publication, how to publish. But now I think you have enough experience, you have enough scope, because the world is moving in that direction, academia is moving in that direction. So you can start now, doing some research and start publishing, so that by the end of masters, you have maybe 5 or 10 publications. Okay. So you have a very strong profile. So any professor will look at your profile, and he just looks at you, he says, okay, this guy has started from bachelor, so he has a strong profile. So he will offer you definitely the scholarship or maybe internship. He will definitely do you. So first thing is, you have to start publishing from now. You have to be inclined towards like big projects, not do like any beam design or any column design. You do some like just for the sake of completing one, like completing a project. You have to don't do that. What I will say, you take a real life scenario. Okay, if you I am telling you, for civil engineers, you come out of your house, you will see a problem. You stay inside our house, you see a problem. Everywhere you can see a problem. So you take a real life problem, do a project, do some publications, add it to your CV, add it to your profile. Okay, then definitely we are there to help you. I become very sad sometimes, because when you have reference, it is very easy to get a PhD or maybe a master's here. But for our CET, we don't have any much scope, not lot of people here. It is very different to difficult to get a like reference here. So which is very which is what makes very easy for the IIT guys. They have everywhere. I think did I make sense or not? Yeah.
Thank you, sir. The next question is by Debashish Nayak. Sir, how do you cope up with the different codes and dimensions across different countries?
Yeah. So this is a very interesting question. In India, we work in SI unit, okay, Newton meter mm. But in here you like US unit, which is foot pound and feet and pound. Here you are. But you know, like what I will say, yeah, I was also trying to cope up like for 2-3 months. But over the period of time, you will be used it. Now I forgot completely Newton meter. Even now, I suppose I am appearing some interview in some like in India somewhere. So at that time, I am converting everything to Newton meter. Then you are expressing, you know. So I think over the period of time, you will be like fluent in like unit conversion actually. But you remember the beauty of the our work is what everywhere you go, if you put a load, the behavior of structure is same. The formula is same that WL square by 12, WL square by 8, WL square by 24. Okay. Everywhere the formula is same. Okay. So only you will get in a moment in a Newton mm or you get in a Gibbs inch. So the fundamental is everywhere same. So it will be easy for you also guys to move from one unit to other unit. And in Europe, still it is Newton mm. So if you go to Europe, there is no problem. Only you come to USA, they have their different style, like own style.
Thank you, sir. The next question is asked by Anisha Nayak. What are the various possible topics, specialized subjects that can be opted for MS?
Okay, first you have to decide which field you are going. Okay. Now you see, you consider the water resource engineering, environmental engineering. Okay. Like you take an example of like computer science engineering. Every day some new research are coming. Every day they are developing a. Every day things are changing. The same way in civil engineering, if you come to environmental, if you come to water resource, every day new topics, every day new methods, every day you will get a new citations. Now you see now 3D concrete, okay, 3D printing. You can print a bridge now. Can you imagine? You can print a bridge. There are machines now. They can print a whole building or bridge. Okay, so there are a lot of topics you can that's how the best way to know it, you know, if you read like different research papers, various research papers, you will know where you are now, what a Chinese guy is doing, what a Japanese guy is doing, what a European guy is doing, or what a guy from American guy is doing. Okay, you can know that. So you have to go through some research papers, then you will come to know your interest. Okay, then you can apply. Otherwise your interest will be somewhere, but you will apply. Don't be blind, like don't be blind like, okay, I have to do only, because everyone's aspiration is I have to do structural engineering. Okay, so that's what, like, I'm saying, don't be only influenced by structural engineering. Try to search other engineering areas, so you will get a lot of interesting technologies, lot of interesting aspects. Yeah, the key is to go through all the research papers. You make a habit of reading some research papers actually.
Thank you, sir. The next
Yeah.
question is asked by Sashwati Behera. Sir, how to create the perfect CV as a civil engineering student?
You know, this is the most important question. Like, you see, how do I look at you? Like, okay, uh, mm, mm, I mean to say, I cannot discuss everything with you in a 1 hour. Suppose now 1 hour is done, so we cannot discuss everything. Okay, you have to create a template like that shows your face. CV shows your face. Okay, like your present face, your future face, everything that shows you. So, mm, like I cannot explain you now, like okay, how to make a CV. This is like this is a whole lesson, like this is a whole lesson. I have to explain you. You know, I am telling you, I have made my CV. It took me to come to a certain level, a acceptable level. It took me 3 months. You can make a CV of 8 pages, 10 pages, 20 pages, or you can present everything in 1 page. So you have to think very carefully. And best thing is what? Like while you do research, you follow other researchers, you do a literature review. The same way, you just see like other big guys CV. Okay. Now there are like a lot of CVs available in internet. Otherwise, we are like I cannot say about others. I am definitely there to help you guys. I can send you my template or some other templates what I have with me. So maybe you get a direction, you just go with that. Then I think you will improve day by day. You can improvise your CV. Yeah.
Thank you, sir. The next question is asked by Priyanka Kaparupu. What are the various job options after completing BTech in civil engineering?
Yeah, now the best job is you go to Odisha government. You become the assistant executive engineer. Okay. Then either you go to software. Okay. And on that day, like I am telling you, okay, Sarthak was telling me, bro, you know, like he was calling me sir. I told, hey man, I have lost my hair, but I am not sir now. You call me bro. So, bro, you know, in computer science, electrical, all these guys are coming from like Oracle, Microsoft. They are coming here. They are giving speech. Okay, I told you know why? Because all you civil guys have gone to Oracle and Microsoft. Your civil, you have become like made your civil branch empty. Okay, at least I am saying you have now 120 people. 10% should come to research. At least 12 people. Other people you go, because if all you go to software or all you go like Odisha government, you will do some paperwork. Okay, who will do the real work? Who will do the real work? So at least 10 people should come here, like 10%. Other 20% you go to Odisha government. Other 20% you have to, you know, distribute yourself. Don't be confined to like one area only, like software, or maybe you go to PSUs, or maybe you prepare for 3 years to get a PSU and go there and do only paperwork. There is nothing for civil engineering, I'm telling you. So you have to, I think, you know, when you are in third year, you have to you have to create your own interest, like whether I should go in structural engineering. Then you have to see the list of companies. Okay, then you have to approach the companies. Okay, and now I just remember one thing. Please try to do as much internship as you can. Okay, and I am telling you, I will help you to get internship, like not inside India, also abroad. Okay, I can definitely help you to get some internship abroad. Okay, I will tell you the tricks, like how to approach the other people. We can have a maybe other day Zoom meeting, so I can, you know, we will be all together and we will discuss about this.
Right. So actually, I was about to ask, like, because this is something where, you know, alumni has to become a mentor and have their, like, you can say all civil engineer students can become your mentees. And then we can have a small sessions. It could be meetings, or like this workshop was like anything. We have never seen such a beautiful workshop till now. A lot of interaction session, a lot of questions coming up. And we are literally looking forward, just because we had this time constraint today. We had to come up and wind up within 1 hour. But so I would like to invite you again, what we were having a discussion, right, with IIT Bhubaneswar and CET Bhubaneswar. We can do a combined webinar session, or it could be like a somewhat like a workshop also of 2 hours where you can actually guide the students towards the right path. I can see a lot of questions coming up, but today we are just how about like sir having a session once again for the
Yeah,
students
yeah,
where you want
definitely.
to see.
And you can
Right.
just send me the questions. I will go through them and I can reply, and maybe I will reply through
Okay.
email or maybe, yeah.
All right, sir. Like even the student team will reach to you. Even we are creating a platform where students can ask questions, and being a mentor, you can actually answer questions also. Suppose if you're not available for every time for a meeting, you can actually answer. It is something like creating a Quora for CET Bhubaneswar. So from the alumni to the students. So we are already working on it. It will be live by like 1 week, and your student team will reach out to you. So even that platform is ready, and we'll provide you these questions as well, which are coming up.
Okay, thank you so much.
Great. Right, sir. Thank you so much for your time. And literally, it was the beautiful webinar we have done till now, like in past 2-3 months. And I really want to thank Sarthak and Aishwarya also to bring up this webinar really good, and the way you conducted. Really appreciate the participation of everyone who took out their time, especially on weekend. Like sir is in the morning hours, but kudos to the students, those who are joining late at night at 8 p.m. that too on a Saturday night. Thank you everyone. Thank you Satya sir again, and looking forward to see you again for a wonderful session one more time. Thank you so much. We are winding up for today's session.
Okay, thank you so much. I also have a great time because I feel like, coming to my, yeah,
Yes.
being at USA,
Right.
I am still in city.
Right.
Yeah.
All
Okay,
right.
thank you so much.
Right.
Thank you so much,
Thank you so
Sarthak.
much, sir. Yeah. So
Yeah.
Sarthak, Aishwarya.
Thank
Yeah.
you.
Thank you so much.
Okay.
Thank you so much, guys.